Well, welcome to the next episode of the Christ-centered cosmic civilization. And we're going to try to think about chemistry, building on what we've thought about alchemy, which is the big foundational discipline, really fundamentally engaging with the substance of the world and its meaning and properties and so on. And then chemistry was a kind of narrowing, breakaway form of that. There's a fascinating book edited by Peter Harrison and John Roberts called Science Without God, Rethinking the History of Scientific Naturalism. It's from 2019, Oxford University Press, and it's looking at the way science became reduced in its theological vision. That like now, scientific explanations kind of invariably exclude any reference to God at all. But that when you go back to before the 19th century, really, there's this a much bigger and more open-minded and thorough understanding of the world that allowed for a full grasp of all aspects of reality. And that kind of very strong division between nature and supernature is something that's kind of plagued the very modern development of science. Past thinkers relied on theological ideas and theological perspectives and presuppositions to enable the scientific investigation, but that's been lost. Anyway, that's an interesting book, and what we're going to do with this is look at chemistry, quite specific. Well, let me begin by thinking about. Let me set out sort of 6 things that we'd like to investigate in the next few episodes. The first is human thinkers have tried to reduce the world to just one thing, or they despair that it's just too many things to ever make sense. So that's something that is very common in classical thought, Greek pagan thought especially, where they'll try to say everything is actually just fire, or everything is actually water, or earth, or air. And if you read those like pre-Socratic philosophers, they have good reasons, good arguments why everything is fire, water, earth, or air. And you can understand how they're going about that. So that's one approach, to say there's actually just one element, one substance that is underneath everything else, and the apparent diversity is only apparent, and that everything, if you can strip away the appearances, you'll find that everything is just the same thing underneath. Or there's an opposite approach that despairs of finding any underlying unity. And the idea then is there's just an infinite number, or an overwhelming number of just discrete things that are not united together with an underlying commonality or harmony. And that the world cannot be understood. It's just endless chaos, kind of. And And both of those things you do actually find in the modern world. And either this attempt to reduce everything to just one thing, and in quite a lot of the desire for like a grand unified theory or a theory of everything, there's this kind of sometimes I detect this desire that's very like this pre-Socratics to reduce everything to just one thing. So what chemistry is, and alchemy before it, is rejecting those kind of things. Either to say there's only one substance or there's just an infinite number of substances, and to try to deal with the world as something that is more sophisticated than that. And so, in a way, chemistry, as we know it today, is based on the Christian idea, that Jesus created one ordered universe with a whole variety, a whole range of chemical elements, and he holds them together. He gives them unity by his powerful word, so that they work together and combine together to produce new things, new effects. Well, let's not run ahead of ourselves, but what we're trying to argue then is that in a Christian view of the universe, we don't need to get lost in either of those futile pagan quests of trying to reduce everything to one thing, or giving up and saying there is no explanation, there's just an infinite number of discrete things. But what Jesus leads us to understand is that there are many things, but they do have a united harmony that can be understood. And he holds those things together. He provides that unity for the universe, and that it's real, rational, and reliable, and so on. There's so many fascinating things like that are often overlooked in the nature of chemistry and the nature of the elements that construct from which the universe is constructed. So remember, when we were looking at alchemy, we noticed how what the alchemists understood was the sort of somewhat spiritual nature of all reality, and that by paying attention to transformations within the elements, chemical elements could undergo, that was giving us a clue to human transformation and ultimately cosmic transformation. And that is still something that is that moral or spiritual character of engaging with material things. People often assume that's gone. The alchemists were silly to think like that. We don't think like that. But I come across it all the time. That same desire for a purified form of elements and a fear of corrupted things, and the desire to purify them, and that the really purified versions of things, materials, elements, substances, are health-giving, life-giving, even granting immortality. So when I go to the supermarket and look along the shelves, it's fascinating the language that is used. Pure water, and there are filters available that you can install in your home in different ways. And the idea is water, if water is compromised and it is filled with impurities, and what must be done is it must be distilled to a completely pure form of water. And there are different processes offered to yield this pure water. I mean, the alchemists of old would have fully appreciated this kind of language and a quest for the distillation of a pure form of the element of water, and that to drink the maximally purified form of water is health-giving. Health-giving. Well, that language is so common in the modern world, particularly with respect not just to water, but all kinds of foods and substances. And there's moral language used. Just today, I saw this, there were drinks offered that contained good bacteria and that they could counteract bad bacteria. And it was literally the language of good and bad. Same with fat. There is good fat and there is bad fat. And it's fascinating that it's moral language that's used to describe substances that we eat. And that the belief is that the purified forms of water, fats, same with all kinds of food, that the idea of things that are grown, and that you will pay more to have food that, like vegetables and fruit, that is purified from fertilizers, insecticides, processes. And the idea is we want a purified form of the carrot or the potato or the apple, and that to be able to have something that is ever closer to the perfect substance, the perfect pure thing. All of this is an alchemical perspective, really, and but it is presented superficially. Although the language is quite moral, good and bad, pure and even unclean. I've even seen that language, that things are pure and things are unclean. That's literally that clean and unclean. It's literally the language of Leviticus. It's priestly, sacrificial, ceremonial language. And it's all the way through our supermarkets, food systems, even cleaning substances like products will yield purity, and there is defilements and so on. But why I'm highlighting this is that we mustn't imagine that that the alchemical perspective is absent. It is still with us in a kind of unacknowledged form, even though the language is as strong as it probably has ever been. But we like, in the main, we don't own that language or think about what we're saying when we're desiring a purity of substance and a purity of food, and we want to exclude defilements and additives and so on. And this belief that this leads to life, and even like the concept of immortality. And people, if you notice how often people are on the quest for immortality, it's a huge thing. Transhumanism, the desire, the quest for immortality for the philosopher's stone, and how is it pursued in ways that our alchemists, many of the ways it's pursued today are things that our alchemist ancestors would regard as ridiculous, totally unhelpful. The idea, for example, of trying to digitize a person and for them to become completely absorbed into a computer form, that's a vile thing, a totally kind of anti-body thing. Whereas the alchemists knew, no, the key to health and the only form of immortality that has any meaning is bodily. Anyway, the reason I'm highlighting this is that we experience this sense of chemistry being something that contains within it these spiritual messages, and that the alchemist's goal of transformation from base to noble, which we saw was to do with redemption, resurrection, the destiny of the entire universe, and so on. Think about this. I have on my desk a pencil, and that is made essentially of carbon. And so that is that's cheap. The pencil that I have came in a pack of 10, and it cost very little. But that carbon, I also have, well, I don't personally have, but in our home we have a diamond. And that is also carbon. And yet the cost of that would be more than 100 times the cost of the pack of the pencils. Both are carbon, and yet one, the base carbon, has been transformed into diamond, something that is of enormous value, much harder, like a compacted, compressed, under great pressure. The base thing becomes, through this kind of death process of enormous pressure, it becomes transfigured, transformed, transmuted into this intensely valuable thing, the diamond. And then the lowliest thing, the base thing, can become the most precious. We see that in chemistry. Many of us own these examples of a base form of carbon and a extremely valuable form of carbon. But it's the same element that has been through a process of death and resurrection. And it is fascinating to know that there is enough carbon in each human being to make, I think is it 10,000 pencils or something? Something like 10,000 pencils. Or the biggest diamond in the world. Biggest diamond in the world. Every human has that amount of carbon in them. So if you just wanted to monetize the sense of a human, like just that sense of the transmutation of the carbon the carbon in them could be seen as merely for pencils, or the most valuable jewel in the entire world. And that human can be seen from either of those perspectives, and what is the transmutation that human goes through. And this is where we're getting into this issue of Christ. What does he do with us? Something else to consider. 95% of the universe, this is as far as we think in standard model at the moment, but the 95% of the universe seems to be made of just 4 basic elements. Hydrogen seems to be about 74%. Helium is it 14%? Oxygen about 10%. Is that right? Carbon 5%. Don't know if I've got those percentages quite right, but of the 90, if we take 95% of the universe, of that 95%, like 3/4 of it is helium, and then is hydrogen, and then the next biggest amount is helium, then oxygen, and then carbon. And then of the remaining 5%, 3% of that is neon, iron, and nitrogen. So think about that. Like, most of the universe is hydrogen. Then lots of it is helium. Then there's quite a bit of oxygen. 5% maybe carbon. Then there's quite a lot of neon, iron, and nitrogen. But so that means all the other elements, 98%, over 98% of the universe, is taken up by just 6 or 7 elements, and all the other elements make up just this tiny amount. So the most common 20 elements make up more than 99% of the universe. And then all the other ones are just this tiny, tiny amount. I find that quite fascinating, that as the universe is right now, the vast majority of the universe is actually made of just a very small number, very small range of elements, let's say 7. And all the other elements are quite rare. But our planet, on planet Earth, we have all kinds of these wonderful elements, loads of them, that are extremely rare in the universe. So in our periodic table of the elements that has loads of them on, most of those are unbelievably rare in the universe as a whole. And yet we have them and experience them and investigate them and can use them. And we might think, oh yeah, all these elements, they're quite. We get used to them, or the idea of all the elements, but in truth, they're exceedingly rare on a cosmic scale. And then these elements, well, we're going to come to the number 8. The number 8 is extremely important when we think about the elements in the universe. And that we'll investigate that perhaps in the next episode. But this sense of I won't say anything about them. So, chemistry. If physics examines the basic forces and energy of the universe, forces and energy, chemistry looks at the elements from which the universe is formed and how these elements react and what can be made of them. Let me just put this in play in this episode, and that will set us up for our next one. So what I'm going to use is an atomic theory to explain the elements. Now, when I say that, that is a problem in a way, because there are many reasons not to accept an atomic view of elements, and that we know it obviously isn't the fundamental explanation of what things are and how they work. There's so many things that are subatomic and completely different ways of understanding how the universe works. But I think it's valuable for the scope of what we're trying to do here, to think of the elements in terms of atoms and the atomic numbers And it might be helpful if you've got a periodic table of the elements handy. I have one on my screen now, and I'm looking at it with them all laid out and color coded. And we want to think about that periodic table of the elements because we want to think about those atomic numbers. And we're going to accept that atomic number model because it is a valuable tool for understanding what's going on. And so if we think of this, what we want to say is that the elements are formed of atoms. Now, again, the word atom means something that can't be divided, and yet we do divide atoms, and there are subatomic particles and so on. But nevertheless, let's not overly complicate this. The elements are formed of atoms that have specific configurations of protons and electrons. Protons and electrons. We'll think about these more next time, and then there's a sort of center to each atom. So if you want to, you might want to look up atoms and see diagrams, classic diagram of an atom where you have a nucleus at the center, and then around that nucleus there are concentric circles around the nucleus, or shells. So the nucleus and then circles around it with, in each of these shells or circles may hold a number of electrons in orbit. Okay. Now, some of you will know this very well. Others will be like, oh, I don't understand all this. And that's why I'm going slowly with it, just because I don't want anyone just being like, oh, this is impossible to understand. It isn't. And we're going to just keep it really quite simple. And that'll be frustrating for some and whatever. But I want to end this episode with, have this idea of the elements, all these different elements that form the universe. That there are kind of building blocks that we'll call atoms. And think of an atom as something that has like a center, a nucleus, with circles of orbiting electrons around that nucleus center. So think of, you might think of our solar system where the sun is at the center and then these planets orbit around it. If you can, many of us will have seen a model of our solar system with the sun and then the planets like Earth orbiting around and Mars orbiting around and Saturn and Jupiter orbiting around. So, but it's kind of like that kind of an image where the nucleus of an atom, that'd be like the sun, and then orbiting around it are these circles that contain electrons. And there'll be a certain amount of electrons in each of these circles that orbit around the nucleus. So a nucleus, and then imagine a circle around that nucleus, and then imagine another circle, a bigger one, a bit further out, and then maybe another circle, even bigger, further out, away from the nucleus. Imagine like something like that, a nucleus with, say, 3 circles. Now, some of them don't have 3. You'll see. Well, I'm at this stage, just imagine such a thing. A nucleus, circle around it, and there's electrons in that. And then imagine another circle outside of that and electrons around that, and so on. That is the image to have in mind. And then in our next episode, we can do something with that image and think about how they work and what that tells us about the nature of the universe, about theology, and about the new creation hope that is written into the universe.